our point assumptions. So always we start with the maximum points that we can possibly get. So first you cross the line, and assuming that 2 robots shoot 3 balls each, you get 9 points. You get 54. And then assuming in teleop you have a 15-second cycle with a 30-second end game, that gives you 7 cycles total, which is absolutely insane. But this is your theoretical max, so we don't really care if it's insane. So you have 3 robots over 7 cycles shooting 5 balls worth 3 points each. That gives you 315 points because you're assuming that we're making it in the dead center in the inner thing. And then the positioning of the little spinny thing is 30 points, and we're just assuming that that happens instantly because it's kind of in this 30-second NDA to slide over time. And then 90 points for the hang gives us an overall of 504 points as like theoretical maximum. This isn't even going to happen in Einstein type stuff. Estimating that you hit maybe 412 at Einstein. Oddly specific, but like that's possible, maybe. And then here's actually like an ideal single target, single robot, assuming 6 cycles with a 15-second end game, and positioning takes 1 cycle for the little spinny thing. So you get 15 points for crossing the line. It's a really big ask. I hope everyone can drive a robot forward. And then not calling anybody out. And then I'm assuming that you actually shoot and make the balls. So that's 18 points there. You hit 90 points of balls shooting 6 cycles. That's actually probably more of a range of like 70 to 90, because some of them, even if you're shooting a perfect robot, you're not going to hit the inner every single time, and you're going to draw points from that. But some people might be able to do it, and we're just ideal. And then positioning, you get 30. Hang, we're only doing a single robot, so that's actually, it's a single robot, so the hang is only 45, but depending on if people can drive into the thing, you would get up to 45 to 55, but that's kind of canceled out by the ideal ball performance. So ideally, for a really good top tier 148 robot, you're hitting somewhere between 190 to 210 points for qualifying. So there's our estimations for point totals so far for this game. It's probably not going to happen in the first week. I would say that this is honestly probably closer to 3rd or 4th week performance.
Hi. This isn't a formal thing to tell you that instead of doing everything poorly like we've done in the past, we're going to focus on one thing and try to be very mediocre at it, which is doing a 3-person hang. That's all, folks.
So we're discussing the buddy climb, triple climb, whatever climb, and we're discussing how you grab a robot. And the proper way to answer that question is to go download the CAD of like 30 other robots and look at them all in CAD and figure out how you grab them. But when have we ever done anything the right way?
Yeah.
So,
the question is, how can we do this without looking at 30 other robots?
we have 1.5 other robots that we can look at, and maybe a kit bot.
But none of them are anywhere legal. They're all robots in 3 days, so they're all
close to legal.
So we took the top frame off of the old robot from last year, and now we're replacing the wheels with our grip wheels. So
we chose to do the 4 kit block wheels and then 2 omnis, so that we can have a little bit of maneuverability at least.
yeah, and it's not going to be that hard. It's just going to take a little time, and then we can actually start working on the rest of this chassis. I'm just gonna let it go.
we have prototyping ideas for this afternoon. We've been talking again about the 3-person climb or the buddy climb. Really, just how do you pick someone up? Because that's the question. We got 3 things we want to try. The common theme to all of them is we're putting forks under people, and we're having them drive over forks. Excuse me. So 3 options. 1, we're gonna hard clamp down on their bumper/frame element and squeeze them into the forks and pick them up. 2, we're going to put a bladder down, inflate the bladder to provide the squeezing pressure, and pick them up. Or 3, we're going to, this one's more complicated, we're going to basically put a ratchet strap around them and ratchet strap them to the forks and pick them up.
So basically for this afternoon, we figured what we're going to do out there is we're going to finish our robot from last year, get that driving, everything all set up, put together.
It was driving at the start of the day.
We had to do some modifications, it's no longer driving. We're going to fix that.
Negative progress.
And we're going to put together a rough mock-up of a robot that we can use to test climbing. And then we're going to get our design for the hanging bar, try to figure out how we can make the full bar with its like pivoting so that we can test our 3-row climb. And we're going to just do a bunch of prototyping as much as we can do.
So we're talking about how to build the our pivot, and so here we are. We were modeling in SolidWorks. A metal pipe costs too much. We're trying to figure out how to save cost. So we were modeling a simulation of the composite of filling a PVC with quickcrete, but we couldn't find the material properties of the quickcrete. So it's time to go to Lowe's anyway.
All right, let's go to Lowe's.